Okay, this is AP Calculus Lecture 4.2. And the first part of today's lecture, in fact, all of today's lecture really doesn't involve any calculus. We're just using concepts that lead to future calculus concepts. The start of today's lecture is called sigma. I introduce you to sigma or summation notation. When we say sigma, that's the Greek capital letter. Is what we're going to use. All right, it looks like a big E. And so, for example, let's say underneath the big capital sigma, I equals 1, and so this is where to start the sum. So again, it's summation. This means sum up. You might have seen this on Microsoft Excel or something, if you ever work with that. So it's where to start a sum, and in means where to end the sum. So let's say that we are wanting to sum up from I equals 1 to n a sub I. Well, how you do that is that's going to be you start at 1 and you just plug in 1 for I. So you'd have a sub 1 plus, and then you just go around and around and around and you increase I by 1 each time. So it'd be plus a sub 2 plus a sub 3 plus a sub 4, and however big n is, then you kind of dot plus a to the n minus 1 plus finally a to the n, however big n is. And so this is a shortcut of writing all that out. Okay? So let's do some examples. So our first one is find the sum I equals 0 to 4 of I squared. So you just start at 0 and then you increase by 1 each time. So think of it as going round and round and round and round until we get to 4. So it'd be 0 squared plus 1 squared plus 2 squared plus 3 squared, and then we end at 4, so plus 4 squared. All right, so you add all that up and you'll get 30. All right, let's do another one. Let's find the sum from I equals 2 to 4 of I cubed. Why don't you pause the video and try this yourself? All right, and then we'll come back. So that's going to be start at 2 cubed plus 3 cubed, and then we end at 4. So plus 4 cubed. Calculator's helpful. That is 99. All right, I'm going to try one more. All right, let's find I equals 4 to 7 of 2I plus 1 over I. All right, let me write this answer underneath here. So that's going to be 2 times 4 plus 1/4 plus 2 times 5 plus 1/5 plus 2 times 6 plus 1/6 plus the last one, 2 times 7 plus 1/7. All right, you can just put all that in your calculator if you want. But you should come out with 44.76. All right, our next little section is, let's say you're given a list of numbers and you then need to try to work backwards and try to find the pattern and put it into sigma notation. So we'll call this rewriting using sigma notation. Okay, so our example is, let's say we have 3 plus 6 plus 9 plus 12 plus 15 plus 18 plus 21. Okay, so we need I is equal to something to something. Okay. Well, it looks like we're increasing by 3 each time, right? So I think we're going to need a 3i. And we're starting, our first number needs to be 3, so I is 1. Our last number is 21, so our last one's going to be 7. So it'd be I is equal to 1. The way you say it is I is equal to from 1. Let me try again. I is from 1 to 7 of 3i. Who cares how you say it? All right, so that is that one. Let me do another one that's a little fancier. Let's say we have 26.5 plus 24.5 plus 22.5, and then kind of dot, 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 so I don't have to write them all. The last one is 2.5. Okay, so what's happening here is you're reducing each one by 2, and then your final one is going to be 2.5. All right, so if we start at 26.5, and then we could say we want to reduce it by 2, so you could say minus 2 times I. Our first I wouldn't start at 1, because if it did, we'd start with 24.5, so it needs to start at 0. And then our last one needs to be 2.5, so that would be minus 24 here, so I would stop at 12. So it's kind of a puzzle. Think about it just a little bit. Try out a few things and just kind of see what works. All right, but that would be that part. So that ends the first part of this lecture, which is summation notation. And we'll go to the second part in just a second. All right, our second part is going to be approximation of area under a curve using rectangles. What a long title. Ha, can't fit it in. All right, approximation of area under curve using rectangles. Goodness. Okay, so I'm going to draw a little graph here. And we're going to have a line. And the equation for the line is f of x is equal to x plus 1. So a slope of 1, y-intercept of 1. Okay, and so, let's see, so this is 1. Let's say this is 2. All right, so what we want to find is what's called the left-hand sum the book calls this, so there's two different ways to say it, but the book calls it the lower sum. All right, so what we're going to do is divide all the area under this into rectangles. Okay, so we want to find the area under the curve from 0 to 2. So we want to find the area of this shape under the curve from 0 to 2. So in our particular case, we're going to do this by dividing it up into 4 rectangles. In the homework, sometimes it'll tell you to do more rectangles, sometimes less. All right, so I'm going to divide it up into 4 equal rectangles. So I'll have a 1 here, a 1/2, and a 3/2. So our rectangles would be like that. Like that. Like that. And like that. Okay, so we're going to approximate the area under the curve by adding up the areas of rectangles, because that's really easy to do, right? So we'll call this rectangle 1, rectangle 2, rectangle 3, and rectangle 4. Okay, so you know that the area of a rectangle is just equal to base times height. All right, so adding up the area of each rectangle gives a good approximation of the area under the curve. All right, so we're going to let n equal our number of rectangles. All right, and in our case, n equals 4. More rectangles will give you a better estimate. But the more rectangles, the more work. Okay, so more rectangles, better estimate. So if we were to put this in sigma notation, then you would say the area is equal to, from I equals 0 to n of delta x times f of x sub I, where delta x is equal to the base and f of x sub I is equal to the height. Now I'm showing you this. This isn't a hard thing to do. I'm showing you this because this is the kind of language you'll see in a calculus book, okay? All right, now we're going to do it mathematically. So go ahead and pause the video if you're still writing. I'm going to erase almost all of this text. Okay, so we've been asked to find the lower sum. Now, our estimate leaves out this part in blue, right? So our estimate is going to be too low. All right, our estimate will be under the actual because our rectangles don't go up all the way to the line. We're leaving out this area in blue, but that's okay. All right, so our total width is 2, right? So the base of each rectangle is 1/2. Okay, so let's get the height. The height and then we'll say the base and then the area. Now when you do a left-hand sum, you take the left, for the x value, you take the left side of the rectangle. Okay, so our height is going to be f of 0, which is 1. That's rectangle 1. All right, let's add a column here. Rectangle 1. Height is 1, base is 1/2, so the area is 1/2. For rectangle 2, that'd be f of 1/2, right? Because the left side is 1/2. 1/2 plus 1, all right? The height is, again, you got to stick it into this. 1/2 plus 1 would be 3/2. The base of that rectangle is always 1/2, so that would be an area of 3/4. Rectangle 3. What we're going to the left side of rectangle 3, it's f of 1. 1 plus 1 is 2. So the height is 2. That doesn't seem right. Oh, I think it, well, yeah, it is. Okay, the height is 2. The base is 1/2. So that's 1. And then rectangle, my graph isn't right here. So that'd be 3, 2, something like that. So that's what's kind of screwed me up. Sorry about that. All right, and then finally, our last rectangle, the left side is 3/2. So we're doing f of 3/2. That'd be 3/2 plus 1, all right? And that is, the base is, so that's 5/2. So that would be an area of 5/4. It might be easier if you want, do it all in decimal. Okay, but that will all add up to 3.5. So that's our estimate. All right, so 3.5, so that'd be, let's see, 2/4. So it'd be 2/4 plus 3 is 5/4. 9/4, 9 and 5 is 14/4. All right, I just want to make sure real quick. That's 3.5, 14 divided by 4. 3.5, yay. Okay, that's our lower sum where we use the left side of the rectangle. We're going to do the same thing with an upper sum. So pause the video if you need to. All right, I'm going to redraw this. Oh man. This exact same function, we're going to find the upper sum. Okay, so we have our line. We want to find the area between, under the curve between 0 and 2. We have 4 rectangles. All right, and when you do the upper sum, what you do is you draw the rectangle starting at the right, and you get an overestimate. All right, draw it up here till you hit the line, and then over. Hit the line, and then over, and okay, so it's rectangle. Un, dos, and that. There you go, that's better. Un, dos, tres, cuatro. Ah. Okay, but you can see this time we're going to get an overestimate because our rectangle is extends above the line. So we want to do the right-hand sum. That's how I learned to say it. The book calls this the upper sum. I believe it does. Okay, so let's make a chart again. Our rectangle. We have our height, our base, and then the area. Okay, rectangle. Un, dos, tres, cuatro. Okay, the height. It's going to be f. Our first one is f of 1/2 because we are starting on the right side of the rectangle. And remember, our equation is f of x equals x plus 1. So 1/2 plus 1 is 3/2. The base is still a half. So that's going to be an area of 3/4. Then we do f of 1, the right side of the second rectangle. That's going to be 2. Base is a half. 1. F of 3/2. 3/2 plus 2/2 is 5/2. Base is a half, always the same. It's a rectangle. 5, that's going to be 5/4. 5/2 times 1/2, 5/4. And then our fourth rectangle, f of deuce. All right, 2 plus 1 is 3. Base is still a half. And that's going to be 3/2. If you add all that up, you get 4.5. So that's your estimate. All right, a right-hand sum on an increasing function gives an overestimate. Now, if it were a decreasing function, it'd be an underestimate, okay? So you kind of have to draw it out. But in this case, it gives an overestimate. So our first one, the underestimate was 3.5. The overestimate was 4.5. What do you think the actual area is? Drum roll, please. Take a guess. Well, it's going to be 4. But it's easy to figure out because this is a shape that we could easily make into a rectangle and a triangle. And you could test the area. And if you do that, it's going to be 4. But we're going to get to areas under the curve that are very fancy, all right? And it's much harder to use a geometry formula to figure out the area. So Go ahead and pause, and then I'll list out your homework. Okay, the homework, page 260, 1 through 9 odd, 35, and 37. All right, 1 through 9 odd are the sigma problems, 35 and 37, the rectangle problems. And I will talk to you next video.